Hey, how's it going, Algebra 2 students? This is Mr. Sheck with your Module 6 test review. This is going to be a quick video because it's just a two-sided review. So a quicker review, I need to make it a quick video because I have students showing up in 25 minutes, so I got to keep this under 25 minutes. So let's hop in right away. Looking at the first one, it's just to write it in radical forms. That means to write it with a root. So this is our radical, and then remember the numerator is our exponent, and the denominator is our root. Simple as that. Done. Okay, moving on to the next one. Now doing the opposite, writing it in rational form, means we need to write our base to a fractional exponent, and again, our exponent, the exponent in our radical form is our numerator, and then our root is our denominator. So 4.1, 8/9, or to the 8/9. Okay, now when we're simplifying, we need to distribute this 3. And remember, when we have an exponent outside of parentheses, we got to multiply it. So it's 3 over 1 times all of these fractional exponents. So 2/5 times 3 over 1, well, that's just a to the 6th fifths. And then for B, we have 3 times 3 is 9 over 1 times 8, so just 8. And then C, we get 3 over 3 when we multiply by 3 over 1. So that's really just going to end up being C to the first, or you don't even need to write an exponent at all. You just leave it as this, and this would be correct. Okay, let's keep cruising. For simplifying now, we have to distribute here, but before even doing that, we have I think it's going to be most useful here to just go ahead and multiply this out. So this first one, or really all of it, they're all in the cube root. So we can go ahead and add exponents. Then 10 plus 4 is 14. 2 plus 7 is 9. So we added the exponents of our a's, added the exponents of our b's. And now from here, we can go ahead and say, well, then that means we have a to the 14 over 3, b to the 9 over 3. Okay, hopefully right away we recognize this b to the 9 over 3 is just going to be b to the third. A to the 14 over 3, well, 3 goes into 14 4 times, so we get a to the fourth. Like we said, b to the 9 over 3 is going to become b to the third. And then we end up getting a to the 14 over 3. Well, so we still have that cube root. But remember, 3 goes into 14 4 times, and then we're ending up with 2 left over. So that's where our 2 left over goes. This is our answer. Okay, moving on down. Simplifying this guy. First things first, if we are taking the square root of x to the fourth, well, and the 8's not going anywhere quite yet, but square root of x to the fourth, that's like saying x to the 4 over 2. So that's just going to become x squared. Now on the bottom, again, this is like saying y to the 5 over 2. So that's going to become, well, we can pull out a y squared because 5 over 2 is 2.5. So we pull out the 2, the y squared, and then we're left with a square root of y, or a y to the 1/2 when we do that division. Now, we got to rationalize our answer here, so we have to multiply by root y over root y. That's going to get rid of our root in our denominator, because remember, we can't have a root in our denominator. So now I go on, and on the top I get 8x squared times root y. Nothing special up there. Now, down here I get, well, the 12y squared. But root y times root y, well, that's just going to be y. So now finally, to completely simplify this, well, 8 over 12 is actually 2/3 when you simplify that. They can both be divided by 4. And then you go ahead and you get x squared root y on the top. And then, well, y squared times y to the first is just y to the third. So that's what you get down on the bottom then. All right, once again, now writing in radical form, these should be all the easiest. The denominator, remember, is our root, so we have the sixth root of 15, and it's just a 1 as our numerator, so it's 15 to the first, but you don't even have to write that, because every number, if you don't see an exponent, it's to the first. And now here, we don't see an exponent, once again, so our numerator is going to be 1, and then it's taking the fourth root, so 4 is our denominator. Those ones should be super easy, hopefully. Number 8, simplifying the fourth root of 81. Some of you are going to look at this and know exactly what the answer is. But really, all you have to do is put 81 to the 1/4 in your calculator, or 81 to the 0.25 power, if you don't know it, and you're going to get 3. Oops, and I just realized you couldn't see what I was doing. But I was mostly talking, not really doing anything, because 81 to the 0.25 or 81 to the 1/4 is 3, because 3 times 3 times 3 times 3 is 81. All right, now here, again, asking the value of n, it's just asking, well, what would it be in rational form or as a fractional exponent? And your exponent in your root is 5, so that's going to be your numerator, and your denominator is going to be 6. So n equals 5/6. Okay, then our exact same thing here. Once again, our exponent is our numerator, and our root is our denominator. Simple as that. Okay, going on to the back side now, we're starting off by looking at this chart. And we have to see, okay, did they convert this correctly for the first one? And remember, our exponent should be our numerator. It is not. Our root should be our denominator. It is not, so they mixed it up here. Okay, now for this next one, think about what this simplifies to. 9, or the fourth root of 9 to the 16th, that's like saying 9 to the 16 over 4. Well, that simplifies to, well, 16 divided by 4 is 4, so that is 9 to the 4th. So this one is true. Now, this next one is like the exact same as this first one. Remember, the exponent needs to be the numerator, and the root needs to be the denominator. They mixed it up. It's false. Okay, and then this one, let's write it as a fractional exponent, because obviously they did some simplifying if they're getting to 1/3. So remember, our exponent is 5, so that goes up top. Our denominator is 15, because that was our root. And when we go ahead and simplify this, well, 5/15 is 1/3. So yeah, 12 to the 1/3. That's true. Because when you divide both these by 5, you get 1/3. All right. Going down to this next one, we have 8 to the 1/3. We can go ahead and do that first, because that's like taking the cube root of 8, which hopefully by now we recognize the cube root of 8 to be 2. And then that means then we just have 2 to the 4/3. Okay? 2 to the 4/3, well, there's a few ways of thinking about this. One, you could just put in 2 to the 4/3 in your calculator, but really that's like saying, okay, 2 to the 4th, well, that's 16. And now we still have to do to the 1/3, or take the cube root of 16. You can't see the work I'm doing, I'm sorry. Or take the cube root of 16. There's a bunch of different ways of thinking about it. And then when you do this, either way, no matter how you thought about it, you should get down to an answer of about 2.5 when you round. Okay, moving down to number 13. When you look at this, we have to multiply our exponents here. That is the rule when you see an exponent to an exponent. You multiply your exponents. Well, if you're going to multiply 1/5 times 5 over 2, the 5s are going to cancel there. So really, you end up with 16 to the 1/2 then, because the 5s are canceling. Because again, here I'll show that maybe better just in case we couldn't see why that was. This is what we have. We have 5 over 1 times 2 over 5, or sorry, 5 times 1 over 2 times 5. The 5's cancel there, or you would get 5 over 10 if you didn't cancel them. Either way, if you didn't cross simplify, either way you're going to get 16 to the 1/2, which is saying the square root of 16, which we know is 4. Okay. Lastly, going down to number 14, it is our final one, so we're going to have plenty of time to spare here for me, which is good. Solve the equation above for x. Well, the first thing you got to do to start getting x alone is you want to get this 4 away, so you got to divide both sides by 4. So let's start by doing that, because when we do that, that's going to get that 4 to go away. So that'll give us y over 4 equals x to the 5th minus 2. Okay, keep trying to get stuff away from x now. That means I got to add 2 to both sides. When I do that, I get x to the 5th equals, right, because those cancel. So I get x to the 5th equals y to the 4th plus 2. And then to get x alone here, I have to take the 5th root of both sides, right? That's what's going to make this guy go away. If I do it to one side, I got to do it to the other. So really your answer here, you could either say it as x equals the 5th root of y over 4 plus 2, or if you want to write it as a fractional exponent, you can do that too. You could say x equals y over 4 plus 2 to the 1/5, like that. So really your choice there. And then going ahead and solving or finding the value of x if y equals 12,492, then all you have to do is go ahead and plug this in for y. And for in your calculator, this will probably be the best way to do it. So I'm going to replace the y with 12492. That is over 4 plus 2, and this is all going to be to the 1/5, or taking the 5th root of it. So when I go ahead and do this part in my calculator, 12492 divided by 4, I get 3,123. And then I need to add 2 to that, so I go ahead and do that. Guess I could be showing you what I'm doing in my calculator, but I'm talking through it. And then now the last thing, right? So I simplified everything in here. I get 3125. That's to the 1/5. Okay, we'll slide this up so you can see better. So then lastly, in my calculator now, I have to raise my answer to the 1/5, and hopefully we know 1/5 is 0.2. So if I just say answer to the 0.2 power, or maybe you know how to enter fractions in your calculator, do it to the 1/5. Or if you didn't know that 1/5 is 0.2, you could on the side do 1 divided by 5. You would get 0.2. Either way, when you do it all, you should get a final answer of 5. And that is your Module 6 review. So mini unit, short review. It'll be a short test. These are the things you've got to know how to do, so please make sure that you can do them. And that is all for now. See you later.